Bismillahirrahmanirrahim. Assalamu alaikum. My name is Fajar and the topic of my practical is determination of aspirin by back titration method. The aim of this practical is to find the concentration of aspirin by back titration method. The chemicals required for these practicals are aspirin tablets. Its formula is C9H8O4. Its structure is given here. Second chemical is ethanol. Its formula is C2H6O. Its formula is given here. Third chemical is phenolphthalein, C20H14O4. It will be used. Chemical is hydrochloric acid. Its concentration should be 37% by weight. And fifth chemical is sodium hydroxide in its standardized solution. The equipments required for this practical are two burettes, mortar and pestle, weighing bottle, water bath, and boiling chips. The procedure of this practical is the experiment consists mainly of two parts: determination of acetyl salicylic acid in aspirin. In the preparation of the 0.1 normal 8.3 ml 12 molar HCl was mixed with water to generate 100 ml 0.1 normal HCl. The volume of the HCl and NaOH used. The standardized HCl was then used in the analysis of the aspirin. In the analysis of the aspirin, 0.1 gram of aspirin sample was founded and a 20 milliliter of the standardized NaOH was added to it. The mixture was boiled then for 10 to 15 minutes. Simmering was done to hydrolyze the aspirin sample. The three trials were made for the analysis of the aspirin. The mixture was cooled and was transferred into a 250 ml volumetric flask. The flask was washed several times with 10 ml portion with the standardized HCl using phenolphthalein as the indicator. Table 3 and 4 show the volume of aspirin, liquid, and HCl used. To calculate the number of moles of NaOH, the formula used was molarity of NaOH times average volume of NaOH used. The molarity of sodium hydroxide is 0.0927 molar, and its volume for every trial is shown in table 2. The computed moles per trial were 1.99 into 10 to the raised power minus 3 mole, 2.16 into 10 to the raised power minus 3 mole, and 1.93 into 10 to the raised power minus 3 moles of sodium was computed by multiplying the molarity of HCl by the volume of HCl used. The molarity of HCl was given as 0.1 molar, and the volume for every trial was given in table 4. The calculated results were 2.4 into 10 to the raised power minus 4 mole, 1.7 into 10 to the raised power minus 4 mole, and 3.2 into 10 to the raised power minus 4 mole for first, second, and third trial respectively. One of the main objectives of this experiment was to determine the concentration of the acid in the aspirin was 8.92 into 10 to the minus 4 mole. The observations of this practical are: concentration of sodium hydroxide is 0.0927 normal, which is equal to 0.0927 molar. Table 1 shows the volume of HCl that was titrated for the standardization of HCl. Table 2 shows the volume of sodium hydroxide used to titrate 25 ml HCl. Mass of aspirin is 0.1074 grams. Table 3 shows the aliquot with the standardized HCl. Table 4 shows the volume of HCl that was used in titration of the ground aspirin. Now we will calculate the volume of NaOH. Weight of aspirin is 250 milligram into 4, which is equal to 1 grams. Formula is percentage of ASA is equal to mole equivalent of NaOH minus mole equivalent of HCl multiplied by 180.2 by 2000 divided by weight of sample multiplied by 100%. By putting the values, we get the volume of sodium hydroxide, which is equal to 10.49 milliliter. 10.49 ml of NaOH was used to hydrolyze 1 gram aspirin, 90% pure acetyl was successfully met, and back titration was properly performed and introduced. It is observed that the volume of NaOH used to titrate HCl do not greatly vary, same as with the volume of HCl used to titrate aspirin. The number of moles of aspirin computed was 8.92 into 10 to the power minus 4 mole. UV visible determination of acetyl salicylic acid in aspirin. Acetyl salicylic acid is a salicylic drug which is commonly used like analgesic, antipyretic, and anti-inflammatory drug. There are a lot of methods for analysis, but we decided for UV visible spectroscopy. In this topic, our correlation results from UV visible determination of ASA in 6 aspirin tablets from different manufacturers in Bosnia using 2 different methods the same way. First method was done using 1 molar sodium hydroxide for degradation of ASA and development of colors with 0.02 molar FeCl3 and 0.03 hydrochloric acid. Optimal pH is equal to 1.6. For this analysis, we made 5 standards with different concentrations, changing pH of FeCl3 HCl solution. Then we changed the concentration range of standards 50 to 250 at 530 nanometer using FeCl3 HCl solution at pH 1.60. So we analyzed samples using that solutions. The second method was resolving standards and samples in concentrated ethanol and measuring absorbance at 227 nanometer. Both methods gave good results and can be used for pharmaceutical research. This is the spectrum of ASA determined by visible spectroscopy. This is the instrument used to discuss NMR determination of ASA in aspirin tablets using different solvents and conditions. In this study, we employed an NMR-based metabolomics technique to identify the manufacturer of various aspirin tablets. Aspirin tablets from 6 different companies were analyzed by 1 Hz 400 megahertz NMR. The acquired data was then integrated and processed for principal component analysis. Based on the NMR data, we were able to identify peaks corresponding to ASA in all of the 6 samples, whereas different NMR patterns were found in the aromatic and aliphatic regions depending on the unique additive group. These observations led to the conclusion with the presence of additives. This is the spectrum of air used in NMR to find ASA. Now we will discuss our Fourier transform infrared spectrometry method to determine acetyl salicylic acid in aspirin tablets using different solvents and conditions. An FTIR spectrometric method was developed for the rapid direct measurement of ASA in different pharmaceutical products. The conventional KBR spectra were compared for the best determination of active substance in drug preparations. The real and 2 chemometric approaches, partially least squares, and principal component regression methods were used in data processing. This is the graph or spectrum obtained by FTIR. This is the FTIR spectrum of ASA standard using the KBR disk method. And this is the instrument used in FTIR to determine ASA. Now we'll discuss mass spectrometry. ASA is a famous drug for cardiovascular diseases in recent years. Effect of ASA dosage on the metabolic profile have not been fully understood. The purpose of our study is to establish a rapid and reliable method to quantify ASA metabolites in biological matrices, especially for then we applied this method to evaluate the effects of ASA dosage on the metabolic and excretion profile of ASA metabolites in rat urine. Salicylic acid, genetic acid, and salicylic acid were determined directly by UHPLC MS. While salicylphenolic glucuronide and salicylic acid phenolic glucuronide were quantified indirectly by measuring the released ASA and SUA from SAPG and SUAPG after beta were the major metabolites of ASA in rat urine. 24 hours after ASA administration, each accounted for 50% SU and 26% SUAPG. When ASA dosage was increased, the contributions dropped to 32% and 18% respectively. The excretion of other three metabolites, however, showed remarkable increases by 16%, 6%, and 4% respectively. In addition, SUA and SUAPG were mainly excreted in the time period of 12 to 24 hours, while GA was excreted in the early time. It was mainly excreted in the time period of 0 to 4 hours and 12 to 24 hours, and the excretion of SAPG was equally distributed in the 4 time periods. We went further to show the excretion of 5 metabolites in rat urine was delayed when ASA dosage was increased. In conclusion, we have developed a rapid and sensitive method to determine the 5 ASA metabolites in rat urine. We showed that the profile of ASA metabolites in rat urine. This is the spectra of ASA obtained by mass spectrometry. And this is the instrument used in mass spectrometry to determine ASA. Thank you.